Hello and welcome. I'm Adeyinka, your SQL coach. In this video, we will explore databases. Databases electronically store and organize data. So we will discuss the structure of databases and the data they contain, preparing us for the practical classes. Okay, so a database is a collection of information that is organized so it can be easily accessed, it can be easily managed and updated. Organization is really important when it comes to database. We are not just storing the data, we have our reasons for storing the data. We are storing it so that we can access it, we can manage it, and we can update it down the line. So a database basically stores data. Let's consider the responsibility of storing and organizing data for a library. It's a case in point. So we might establish a database containing information on patrons, on books, on checkout. So this data is organized into tables, with each table representing an object. So the data organized into rows and columns. This database consists of, let's say, patron table. Yeah, you can see that. Books table, checkout table. Taking a closer look at the patron table we have there, reveals that it stores various data about the library's patron, such as the library card number, the name, the year the patron became a member of the library, and the total overdue fines owed to the library. So here is a collection of information about people. This is another example. Their name, where they live, their age. So look at this. Hello, my name is Victor. I'm 21. I'm from Jos. So I'm Bernard, born in Haba, but now live in Lagos, etc. You can, as a human, read that and interpret it and extract things like, okay, this is the name, this is the ages, and these are the locations. So, but not easy if you have like 1,000 items to vet that way, or let's say it's going to millions and billions of data you have to look into. So it's not going to be easy. It's going to be very, very, very time consuming. Yeah, using a computer system for you to write some codes to extract the names, ages, locations would be very tricky because there is no structure. So you are trying to convert an unstructured data to a structured data. So it's going to be a serious task with a computer system when it comes to a large data set like that. If it's something like 10, you can do it yourself, but you have to code it. And you know where the problem lies? The inconsistencies. There is no consistency. For example, we have what we can refer to as distractors. I'm born in Aba, but now I live in Lagos, so it's not straightforward. Also, some people that reported Abuja in a response, other people can report FCT. So you will now start, coding that won't be easy. Okay, Abuja for one person. How your system will now know that Abuja is still the same thing as FCT, and it won't record it as a separate response. And even when it comes to FCT, some people will start with F, capital F, then small letter C and T. It's different from somebody that wrote everything in capital letters. So there's always problems with unstructured data. When your data is not structured, that's a big problem. So the first problem is problem of consistency. We also have the other problem, which I will explain as we go on. So, as I said, for a computer, at least having that structure is much more preferable. So that's why we engage in database management. Now, let me explain better so that you can understand. For example, if you have a text file or a CSV file where you have got names, locations, age in a much more structured format, CSV file. So got a sort of header row name, the column name, the location, the age. So each bit of data is separated by a command for a CSV file. So this is a database. That's a database. Once it becomes structured, it becomes a nice database. So although you may be wondering that why will I call that a database? Yes, it's really a database, but then it's a simple database because in effect we have got just a table on that database. So we have got columns and we have got rows. Now that type of database is what we call a database that contains only one table. It's called a flat file database. And not so useful. So they don't scale very well because we have got lots of data packed together. There's no. But one thing I would like us to take note of in that is that there are two words that are very important when it comes to database. Number one is records, and number two is feeds. Records are the rows. They are really our rows in the database, and the feeds are really our columns. We have a fixed amount of column in a database because it's initiated while creating the database, but the number of rows are unlimited. You can continue to add more rows, as more clients make their transaction, more rows are generated. As more respondents in the survey responses, more rows are generated. I believe we understand that. So, but the number of columns are fixed. So when it comes to when you talk about databases, think record for row and think feed for column. Very important. Records for row and feed for column. Those are the basic things we need to understand before we move to the practicals. The intersection of a feed and a record is the actual individual bit of data. And now I believe you can see the reason why the structure in databases is very important. It makes our work easier. Without too much difficulty, one can write codes which can interpret the database. That is why structure in database is very important. Now, a better database compared to the flat file database, also known as the non-relational database, is a relational database which has multiple tables that are connected. They are connected through feeds. That is the primary key and the foreign key, the key feeds. A relational database establishes relationship between tables of data within the database. For instance, each library patron may be associated with several checkouts. The relationships enable us to draw conclusions about data in different tables within the same database and answers questions like, okay, which book did James check out in 2022? Or which books are checked out most frequently? So before we go, let's just mention another key bit of terminology. I've mentioned it earlier. That's the primary key and the foreign key. So a primary key in a database is a feed that is unique for every record in a particular table, and that's why we call it a unique identifier, because no element in a primary key is the same. They are all unique. You can't have things like 1, 2, 2, 1, 3. No. Each number, if it's in form of number, which is almost the case every time, in a primary key is unique, different. At times we call them identification number, ID. Each table in a database must have a primary key. Is very important, and one fundamental attribute of a primary key is that all entries in a primary key are different. In form of numbers, they are different. At times we call them identification number. One thing that you should take note is that a primary key in one table is a foreign key in other tables of that database. Once when I'm working with a table, the primary key of that table is a foreign key in other tables in the same database. If you are making a formal database, you need to make sure that you have a primary key for every table in the database. You must have a unique feed, otherwise you can't uniquely identify a record. Here, look at this. We have got Mr. Browns, two of them as teachers. So how do we differentiate between the two Mr. Browns in that teacher table? So it's only by the teacher code. So teacher code here is the primary key for the teacher's table here. So you wouldn't be able to distinguish between the two if there were no other information. So whereas if you have a teacher code, it narrows it down to just one record. You can look at that. So this is important when we start the practicals. So this becomes very important by the time we want to start looking at our database. Maybe we want to make a change or want to search for a particular stuff in the database. So this becomes very important. So it doesn't matter what it is. It can be a number, it can be a code. In this case, often an ID, identification number. So watch out for this, and you need to have one in every table. Very important. Now, what are the advantages of database? Let's talk about them briefly. After this particular video, we'll be doing more of practicals. So while tables may resemble the organization of data in spreadsheets like Excel, like Google Sheets, databases often offer more power and security through encryption. There's one thing about database that talks about encryption. We still deal with it in the practical. When you code, when you password your data. So databases can store extensive data and their storage is more secure. So when it comes to security, that's one of the fantastic things when it comes to relational database. I'm talking in terms of relational database now. So one significant advantage of databases is the ability for multiple users to write queries simultaneously. That's another advantage. Multiple users can work on the same database at the same time. So gathering insights from the data. When the database is queried, the stored data remains unchanged. That's very wonderful. So it helps with gathering insight from the data. So database query doesn't change the database, doesn't change the stored data. It remains unchanged. Instead, the information is accessed and presented based on the query instructions. So this brings us to the star of the show, SQL. That's really why we are here. SQL, which is short form of Structured Query Language, also pronounced as SQL. So if you like, SQL is the most widely used programming language for creating, querying, and updating relational databases. So once we familiarize ourselves with the stored data and its corresponding tables, we can use SQL to write queries and obtain answers about our library. Don't forget, it doesn't change the data. So more on that in the next video. Okay, so the next thing we would like to discuss is to compare relational versus non-relational databases. I told you that relational database in form of SQL, in form of Oracle, MySQL, other variants of SQL. Also, the non-relational databases can be in the form of Excel, they can be in the form of Google Sheets. So those are non-relational databases. They don't have the power like the relational databases, which have encryption, security, multiple tables. They don't do that. Now that are connected, Excel has multiple sheets, but the connectivity, how is it? Now, these are two different ways to store the data, both the relational and the non-relational databases, and also operationalize the data. We know there is so much data coming to every company. Every single company has large data, big data. So today, but then when it comes to customer preference, customers prefer that. They always prefer to just express themselves in unstructured manner. They don't like when it comes to come and fill this form. They start looking the other way. So when it comes to scalability, getting more clients, you need to have you would prefer to go the unstructured way, so that more people will be interested in patronizing you. So that's why phone calls are allowed, all those things. So if you just say, okay, go to your app, we pressing buttons, not everybody is interested in that, and but not even everybody has the technical know-how for that. So when it comes to scalability, unstructured and non-relational databases are actually more demanded for when it comes to scalability and flexibility. So we know that there are so much data coming to companies. Customers prefer to actually fill their data in an unstructured way, because for them that is flexible and scalable. They won't mind coming back tomorrow. Imagine if you wanted to transfer, you just chat up Zenith Bank on WhatsApp, help me to transfer something to my account, instead of the usual way of going through mobile app and the rest. So we know there's so much. It's important that customers have options. It's a preference. So for how they want to maybe provide their purchase data, so many prefer through chats or emails. So let's start with relational databases. Relational databases are a very structured way to store your data, but to really understand the relational database, first we need to understand the table. All the data is stored in tables, and those tables are connected to each other. That's why we call them relational. Use the term relational for them, and they are connected, right? They are connected to each other, so they all have relations with each other. Relational databases are a very structured way to view the information that's coming into a company. So with that, there are lots of benefits, I tell you. One of them is that the structure really ensures data consistency. There's no Abuja here, FCT there. So this also helps with security. Relational database also helps to secure your data. Let's say you're in an hospital and you have lots of patients. You have information about their medical history, what medications are taken. So these are all protected when it comes to relational database like SQL. They are all protected. They are encrypted with passwords. So using a relational database, you can encrypt certain tables. You can hide information. You can make sure the right people have access to the right data. So, and then finally, we have ease of backup and recovery when it comes to relational database. So because this data is very consistent and at all times it remains consistent, it's easy to save the database at any point and it's easy to recover from what you recently have. So this gives us an idea of what a relational database looks like. Alright, on the other hand, we have the non-relational databases. So this is different from the structured approach. We have the unstructured data here. So there are, let's say, different types of non-relational databases. In fact, we have more types of non-relational databases than we have for the relational database, and that's even one of the reasons why clients prefer non-relational database. Customers, they prefer non-relational databases. So okay, the first, we have different types. As I said, we have the graph database, we have the key value databases, we have the column store databases, we have the graph databases. Graph databases shows different entities in the database and how they are connected with each other in a graphical way. So that graphical way, that's the non-relational database. So we have the document store databases, it's also non-relational. So finally, as I said, we have the document store databases. So this has data and documents, and a group of documents is known as a collection, and document can be recovered in form of collection. So as you can see, there are more options here with non-relational databases, and that's really why customers might choose non-relational option as opposed to the relational databases. So there are added flexibility, as I said earlier, with non-relational databases. There are scalability reasons. So that's really one of the key differentiators why customers choose non-relational database over relational. The scalability. It's easy to scale non-relational databases. Like maybe you are using it for one person, you can use it for 100, 1000, it's easy to generate. That's it. So non-relational databases are easy to scale. That's it. So that means that they can essentially scale out without adding more resources. You don't need to start adding more resources. And finally, they are cost effective, and that's because we don't need to add more resources, then they are cost effective. So this ties back to scalability. But you are able to scale and add more data without more resources, without additional resources. So we can see that we have a lot of different ways in which customers can store their information and make sense of all the data that's coming into a company. So there are different ways people can leverage both of these databases, the relational and the non-relational. There are different use cases. People might use relational databases for more traditional workloads. So if you have a point of sale system, if you are tracking a large amount of records and you want to do so in a very structured way, then if you are the relational databases might be what you are going to go for. So but if you are developing a new application, you want more customers, you want more clients, so you want added flexibility, then customers might differ to a non-relational database. But either way, our clients have options as to how they want their data to be stored and how they want to best operationalize it. So we have the consumer king system. Now tables. I want us to talk about tables before we leave. Before the end of this video, let's briefly talk about tables. Now we understand the basic organization of a database. let's take a closer look at the main building block of databases. What are the main building block of databases? They are tables. Tables are the main building blocks. Tables are organized into rows and columns in the world of databases. Rows are often referred to as records and columns as feeds. A table's feeds are limited to those set when the database were created, but the number of rows are unlimited. I've said that before. The number of rows can be as much as we want. We can always add another row, but from time of creation, the table's feeds, the number of columns are limited. Let's talk about good table manners. Let's start with the title. The title of the table itself, or what we call the table name. It should be lowercase and it should be one word, meaning it should not involve spaces. Instead of spaces, we can use underscore, and it can be in plural form. Table names, not column name, not row title. So ideally, a table name refers to a collective group, let's say inventory, but it's also okay for a table to have a plural name such as products. Okay. Now, records. A record. Let's talk about records before we continue with the table manners. Just for I know I've said it before, I still want to say it again. A record is a row in a table holding data on an individual observation. For example, the patron table we discussed earlier, we see that the table has 4 records, one for each patron. So the record for Jasmine indicates that she became a member in 2022 and holds $2.05 in fines. Let's talk about feeds. A feed is a column in a table holding one piece of information about all observation in the table. So the name feed, for example, in the patrons table lists all the names of our library patrons. So more table manners. Now let's talk about more table manners. When we talk about feed names, it must be typed out when querying database with SQL. So feed naming is crucial. Generally, feed names should be in lowercase and should not involve spaces. Feed names, column names should not involve spaces. A feed name should be singular, not plural. So because it refers to the information contained in that feed for a single record. So each record stands alone. So this is why our table has card number and then name, not card numbers, not names. That's wrong for a column title, or what we call the feed name. So 2 feeds in a table cannot have the same name. That's not possible. Feed names, column names should never share the name of the table they are housed in. It's not possible. The table cannot be products and then in one of the columns you still have product. It's very wrong. So feed names should never share a name with the table they are housed in, ensuring clarity in all cases. So a unique identifier, sometimes called a key, is just what it sounds like, a unique value that identifies a record, distinguishing it from other records in the same table. So this value is often a number. In patrons table, for example, it makes sense to use the card number feed as the unique identifier for each patron, not the name feed, because it's possible that our little library grows, 2 patrons might have the same name. So we need a unique identifier. So having more tables, each with a clearly marked subject, is generally better than having fewer tables. where information about multiple objects is combined. Look at that. So clearly marked subject is generally better than fewer tables where information about multiple subjects is combined. Take a look at the patrons and checkout tables. Now here's what our patron. Now let's take note of this. Having more tables, each with a clearly marked subject, is generally better than having fewer tables where information about multiple subjects is combined. So take a look at patron and checkout tables. Now here's what our patrons and checkout tables would look like if we try to combine them. Look at this. So it's the same data but much less clear because it now contains duplicate information. Look at that. While we can see that Easy has 2 checkout and Maham has none, the card num column is no longer unique. Look at that, because of Easy's multiple checkouts. So we can always use SQL to gather information from multiple related tables. The number of tables is not a problem, and connect them if a question requires it. But table topics should remain separate. Thank you.